Okay, this video is extension, meaning it won't show up on the power assignment, but it may show up on the portfolio, and it's also just good information in general because future courses may expect you to be familiar with it. Now, it turns out that if you know you're dealing with a right triangle, because you already know one of the angles, because you always have that 90-degree angle in the corner, you can take it from 3 things you need to know down to 2 things that you need to know. So the question is, of these, which ones will prove that 2 right triangles are congruent? Now here, when you see the letter L, it stands for leg, meaning the 2 sides that make the right angle. Those are called the legs. So a leg over here and then a leg at the bottom. The H stands for hypotenuse. That would be the longer side that is always across from the right angle. And then the A refers to an angle that isn't the right angle. So let's just run through them. If in 2 right triangles, I know that I have a set of legs that match and then another set of legs that match. Well, basically, isn't that just SAS? SAS, side angle side? It looks like it to me. So yeah, leg is going to work. LL is basically just the right triangle version of SAS. That one's going to work. Okay, let's check the next one now. If I know that I have a leg that matches and a hypotenuse that matches. So an H and an L. Hypotenuse matches, a leg matches. Is that enough information to prove that 2 right triangles are congruent? I want you to think for a moment about your Pythagorean theorem. That's the one that says that, hey, a squared plus b squared equals c squared. That means if I know any 2 sides of a right triangle, we can figure out what the third one is. And whatever number you get for the third length here is going to be the same number you get for the third length here. So if you know H and L, you actually know both L's, which basically means it's just kind of LL again. So yeah, that's going to work just fine. And with these right triangles, you really don't need to check that much. Let's keep going. So HL works, LL works. What if we now start bringing an angle into it? So what if I know that I have, say, a leg that matches? Let me get back to my pen here. I'll tell you what, we'll just leave the highlight there for right now. And then one of the angles, well, there's only 2 possibilities. If it's this top angle here, well, then what we have is ASA, angle side angle. And we already know that works. Okay, what if it is instead the other angle? Well, then it's AAS. And that's another method that we know already works. So yeah, LA, that's going to work every single time. Let's keep checking. This is super handy. So for the next one then, this would be HA. So I know my hypotenuse sides are the same length. And then I know that I have a set of matching angles. Okay, well, if it's the top, that's AAS. AAS, that works. If instead it's this other angle that I know matches, well, then it's still AAS. So in either case, yeah, I have enough information to prove that those 2 triangles are congruent. And then lastly, what if I know that the top angle here matches and the bottom angle here matches? Is that enough information to prove that the 2 triangles are congruent? No. Unfortunately, this is the one that doesn't work. This is equivalent to the AAA version that we looked at in the previous lesson. You can prove that your 2 right triangles are similar, but you cannot, without a side length, prove that they are the same size. So unfortunately, AA is not an effective way to prove that those two triangles are congruent. So in summary, when you're dealing with a right triangle, these are the 4 different methods that can get you there, proving that congruency.